these problems, we're going to be looking at the horizontal and vertical asymptotes of rational functions. The first function is r of x, which equals the product of x plus 1 and x minus 3 divided by the product of x plus 3 and x minus 7. We are to find the vertical asymptotes. We find the vertical asymptotes by finding out where the denominator is equal to 0. And so in this case, we have that x plus 3 times x minus 7 equals 0 if and only if x plus 3 equals 0 or x minus 7 equals 0. So x equals negative 3 or x equals 7. These are the points that cannot be used in the domain of the function. They also give the equation of the vertical lines that are the asymptotes. So x equals negative 3 is the equation of a vertical line, and x equals 7 is the equation of a vertical line. In the second problem, we have the quotient of x plus 1 times x minus 3 over x plus 3 times x minus 7. And we're looking for the horizontal asymptote this time. In this case, for a horizontal asymptote, we want to know the degree of the numerator and the denominator. By multiplying, we can see the degree better. The numerator becomes x squared minus 2x minus 3. The denominator x squared minus 4x minus 21. So they have the same degree, and the leading coefficient in each case is 1. So the horizontal asymptote is found by dividing the leading degree of the numerator, or the leading coefficient of the numerator, by the leading coefficient of the denominator. 1 over 1 is in fact 1. So the line y equals 1 is the horizontal asymptote for this function. Notice that 1 would be the quotient if you divided the denominator into the numerator. The quotient would be 1. There would be a remainder as well, but the quotient corresponds, when it is a constant, to the horizontal asymptote. So let's look at a couple more examples. Here we have the function 7x minus 8 divided by x squared minus 4. And so looking for the vertical asymptotes first, there are 2 of them. If we factor the denominator, we get x plus 2 times x minus 2. Therefore, the 2 vertical asymptotes are x equals negative 2 and x equals positive 2. This time, the degree of the numerator is 1, the degree of the denominator is 2, and so the quotient, if we divided, would be 0. And so y equals 0 is the horizontal asymptote. Actually, any time the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be y equals 0. Continuing now, this next one, we have 8x minus 1 over x squared plus x plus 1. The degree of the numerator is less than the degree of the denominator, and so the horizontal asymptote is going to be the x-axis, or y equals 0. This time, when we look at the denominator, it's not easily factored, and so let's look at the quadratic formula, which would give us -1 plus or minus the square root of 1 squared, which would be 1, minus 4 times a times c all over 2a. This gives us -1 plus or minus the square root of -3 over 2. These zeros are imaginary. And so in this case, the vertical asymptotes do not exist. There are no real numbers that are zeros of the denominator. In the next problem, we have 4x squared plus 1 divided by 2x squared plus 9x minus 5. This time, the degrees are the same. The leading coefficients are 4 and 2. So the horizontal asymptote is going to be y equals 4 divided by 2. That gives you y equals 2. Now, I do think that the denominator factors in this particular example over the real numbers. I think if we use 2x in the first factor with x in the second and -1 and +5. So the factors 2x minus 1 and x plus 5 for the denominator. We're going to get 2x squared plus 10x minus 1x, which gives us 9x minus 5. So the zeros of the denominator are where 2x minus 1 equals 0 and where x plus 5 equals 0. So x equals 1/2 and x equals -5 are the zeros in the denominator, and the equations of those vertical asymptotes are x equals -5 and x equals 1/2. So 2 vertical and 2 horizontal asymptotes that time. In the next example, we have the quotient of 5x minus 1 and x plus 1 in the numerator. We have the product of 5x minus 1 and x plus 1 in the numerator, and 7x minus 1 times x plus 4 in the denominator. So as far as vertical asymptotes, we can see the zeros in the denominator are 1/7 and -4. So x equals 1/7 and x equals -4 are the equations of the vertical lines, which are the vertical asymptotes in this case. In terms of the horizontal asymptote, notice that we have a quadratic function both in the top and the bottom of this rational function. We'd have 5x squared plus 4x minus 1 over 7x squared plus 27x minus 4. What's important here is that the degrees are the same. The quotient of the leading coefficients is the fraction 5/7. And you do want to be exact. Do not use a decimal approximation. And we have two problems left. 2x cubed divided by x cubed plus 2x squared plus 9x. We do notice that the denominator factors with a common factor of x, and x squared plus 2x plus 9. So a monomial times a trinomial. And so we can see that one of the vertical asymptotes is x equals 0. There may be more depending on the zeros of the quadratic factor in the denominator. So the opposite of b, plus or minus b squared minus 4ac all over 2a. It's going to give us negative 2 plus or minus the square root of 4 minus 36, which is negative 32 all over 2. These are imaginary zeros and do not yield any additional vertical asymptotes. In terms of the horizontal asymptotes, we do have degree 3 in the numerator and denominator, and so the leading coefficients are 2 and 1. 2 divided by 1 is 2. If we divided the denominator into the numerator, the quotient would be 2, and y equals 2 is the horizontal asymptote. In the last problem, we only have one 0 in the denominator. It is x equals 3. And the degree of the top is larger than the degree of the bottom. And so there are not going to be any horizontal asymptotes in this case. In this case, the degree of the top is 1 more than the degree of the bottom. So when we divide the denominator into the numerator, we would get a quotient which is a linear function, and we would get what's called a slant or oblique asymptote, which we will look at in a future video.